Now let's look at the first example problem, minimum pass sum. So we are given a n by n grid, which are filled with non-negative numbers, and your goal is to find the path from the top left to the bottom right, so from here to here. And you want the path minimize the sum of all the numbers along its path. And also you're only allowed to move either down or right at any point in time. So encourage you to think, given this, what would be the answer? So the shortest path is shortest path in the sense of with the minimum sum is here. So 1 3 1 1 1. So then that gives us a output of 7. So I guess the second shortest is probably this one, 1 1 4 2 1, which is 9. So how do we solve this problem? So dynamic programming, the way I think about it is about you assume that you have solved some partial or some part of your problem. Then you figure out how to solve the whole. So for example, for here, how do I find out the minimum path and that start from here and ending at here? So I can think about all the paths that start from the beginning, and then for each of the cells, I need to figure out the shortest path, the minimum, the one with minimum sum. I'll just call it the shortest path. The shortest path that stop at that particular cell. So if I want to figure out the answer, the last step to figure out what is the shortest path that ending at here, then the previous step must be either here or here. And whichever one gives us a smaller sum, I'm going to use that one. So then, even though I don't know the whole path, then suppose I have already computed all the shortest paths ending, or at least the sum value ending at each of the cells other than the last one, then I can find out the answer for the last one. So given that, then, and also given there's a beginning, I know the shortest path ending at here, which is just the cell itself, and the value is 1. So given that, and given that we can gradually compute the answer of more cells, then the problem can be solved. So this is very similar to mathematical induction in creating proof. So all you're trying to do is to be able to do one step. If you have a beginning and you have one step, then you can do all steps. So that's the way I would like to think about dynamic programming, is to think about just one step. So what do you need to compute the last step? So then, of course, we have to define something as a step. So typically, it's done using an array. That's not the only way to do it, but I think for all the problem in this set, certainly we can do it that way. So there's also a top-down recursive way to do it. But I think this table way is better matching this kind of problem where there is a kind of matrix to start with. So we define this dpij to be the minimum path sum ending at ij. And my personal experience, when you write programming, dynamic programming, write a comment on your DP array definition of what exactly does it mean. So what exactly does dpij mean? So that will both help you think and help you code. So suppose dpij, we define dpij to be the minimum path ending at ij, then how to compute dpij? So actually, I guess we can see this is the computed the DP value for this particular one. So the minimum path ending at here is 4. That's going here 1 plus 3. So as we mentioned earlier, this dpij would be the minimum of the, if ij is here, we want to look at the cell on top and the cell to the left. Which one had the smallest sum? We're going to use that one, and then we need to add the current value. So dpij is There's actually a missing parenthesis here, so let me add it. So it's a mean of these two, and then plus aij. So for this kind of problem, there are two ways of setting up a DP table. One of them is we use the actual row and actual column, which is the method we are showing here. So this, and the other way is to have exactly the same size table as this one. For this question, because it's fairly straightforward, there's really no difference. Sometimes using one is easier to write code than the other, because otherwise you need to do a lot of boundary check. So here we're just going to show both. So when I do this, because I cannot actually reach these cells outside the boundary. So when I look at, for example, the cell here, 3, I want to see the cell to the left and the cell on top. So the cell on top is actually not reachable. So I want to initialize their cost to be infinity. But the first cell here, I want it to be 1. So in order to do that, I use, I guess, a slightly hacky thing to set this thing to be 0. So then for every cell, the code is the same. So there's no special case in this loop. We are computing the DP value of all of these cells. What we do is we look at the cell on top, we look at the cell on the left, we take the mean, and then we add the current value. So then by setting this as 0, so then this cell will get a value which is just the value of the cell here. So that achieves this objective. I can set this 0 or this 0 or both 0, so that's doesn't really matter. Or I can keep all of them at infinity and then initialize this thing specially as 1. So that's also fine. But the way I do it here, the only advantage in this loop that I fill all the DP cells, there's no check, so it's all the same. So the second method is the table is the same as the same size as the original array. So because for every cell we're going to look at the top and to the left, I need to make sure those values exist. Otherwise, I'm accessing things that are outside the boundary. So then I have to pre-compute their values. So for this problem, pre-computing the value for first row and first column is fairly straightforward. We're just computing essentially prefix sums. So here it's 1 plus 3, here is 1 plus 3 plus 1. And similarly here is these 2 come from 1 plus 1, these 6 come from 1 plus 1 plus 4. So after the first row and first column is initialized, then the rest of the matrix can be filled in using this recursion relation. So for solving problem using DP, so it's important to write down your definition of exactly what you are computing, and then figuring out this recursion relationship, and then setting things up, setting up the initial value correctly, and then you're done.